Let's delve into the pros, cons, and issues associated with different voltages and wiring configurations. First, let's consider the different voltages, beginning with 120 volts. One of the primary advantages of 120 volts is its safety. The lower voltage presents less risk of electric shock and electrocution, making it suitable for general use. Additionally, 120 volts enjoys widespread compatibility. Most household appliances and devices are specifically designed to operate on 120 volts, ensuring seamless integration. Furthermore, 120 volts is readily available in both residential and light commercial settings, making it easily accessible. However, 120 volts also has limitations. Its current limitations can restrict the power capacity of appliances and circuits. Moreover, it exhibits lower energy efficiency, requiring a higher amperage draw for equivalent power output compared to higher voltages. Now let's consider 240 volts. A significant advantage of 240 volts is its higher power capacity. It can accommodate more demanding appliances and equipment, making it suitable for items like dryers and ovens. Furthermore, 240 volts offers improved energy efficiency with a lower amperage draw for equivalent power output, reducing energy loss. It is usable for both residential and commercial applications. However, 240 volts presents safety concerns. It requires special precautions and grounding due to the higher voltage. It also has compatibility limitations, as it is not as common as 120 volts for standard household appliances and requires specific 240 volt outlets. Finally, let's examine 480 volts. A key advantage of 480 volts is its highest power capacity. It is ideally suited for commercial and industrial applications demanding substantial power. Moreover, 480 volts delivers the best energy efficiency, exhibiting the lowest amperage draw for equivalent power output, minimizing energy consumption. However, 480 volts necessitates stringent safety measures. Handling 480 volts requires extreme caution and specialized training due to the high risk of electrical hazards. It also faces compatibility limitations, being exclusively used for specific equipment and rarely found in residential settings. Now let's move on to the types of wiring configurations, starting with two-wire systems. Two-wire systems consist of two conductors, a hot wire and a neutral wire. They are typically used for basic lighting and low-power circuits. However, they may not provide adequate grounding for high-power appliances, potentially increasing the risk of electrical shock. Next, let's consider three-wire systems. Three-wire systems include two hot wires, a neutral wire, and a ground wire. They offer improved grounding and safety, making them suitable for higher power circuits. Three-wire systems are required for most modern household appliances and outlets. Finally, let's discuss dedicated circuits. A dedicated circuit is specifically assigned to a single appliance or device. It provides consistent power and isolation from other circuits, preventing overloading and potential electrical issues. Dedicated circuits are essential for high-power appliances such as refrigerators, air conditioners, and ovens, ensuring their safe and reliable operation. The National Electrical Code, or NEC, provides guidelines for safe and effective electrical installations. This includes conductor sizing, overcurrent protection, and grounding requirements. Following the NEC helps ensure electrical systems are safe and reliable. Consider conductor sizing. The appropriate conductor size depends on the ampacity of the circuit. NEC Table 310.15b16 provides ampacity ratings for various conductor types and sizes. Using the correct conductor size prevents overheating and potential fire hazards. Now consider overcurrent protection. Circuit breakers and fuses are used to protect circuits from overcurrent conditions. The overcurrent protection device should be sized appropriately for the circuit's ampacity. This prevents damage to equipment and reduces the risk of electrical fires. Now grounding and bonding. Grounding and bonding are critical for electrical safety. Grounding provides a low impedance path for fault current to return to the source, tripping the overcurrent protection device. Bonding ensures that all metallic parts are at the same potential, reducing the risk of electric shock. Grounding and bonding requirements are covered in NEC Article 250. Voltage drop is also an important consideration in electrical system design. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting voltage drop to 3% for branch circuits and 5% for feeders. Now for some practical examples. Firstly, consider a 120 volt, 20 amp circuit. According to NEC Table 310.15b16, a 12 American wire gauge copper conductor with THHN insulation is suitable for this circuit. A 20 amp circuit breaker should be used for overcurrent protection. Secondly, consider a 240 volt, 30 amp circuit for an electric dryer. A 10 American wire gauge copper conductor with THHN insulation is suitable for this circuit. A 30 amp, 2-pole circuit breaker should be used for overcurrent protection. Thirdly, consider a 480 volt, 100 amp circuit for industrial equipment. A 3 American wire gauge copper conductor with THHN insulation is suitable for this circuit. A 100 amp circuit breaker should be used for overcurrent protection. The NEC provides specific requirements for different types of occupancies, including residential, commercial, and industrial. These requirements address unique electrical needs and safety considerations for each type of occupancy. In residential occupancies, the NEC focuses on protecting occupants from electrical shock and fire hazards. This includes requirements for ground fault circuit interrupters, or GFCIs, arc fault circuit interrupters, or RFCIs, and tamper-resistant receptacles. In commercial occupancies, the NEC addresses the electrical needs of businesses and public spaces. This includes requirements for emergency lighting, fire alarm systems, and accessibility. In industrial occupancies, the NEC focuses on the electrical needs of manufacturing facilities and other industrial sites. This includes requirements for hazardous locations, motor control centers, and high-voltage equipment. In addition to the NEC, local codes and standards may also apply to electrical installations. It is important to consult with local authorities to ensure compliance with all applicable requirements. Electrical safety is paramount. Always follow safe work practices when working with electricity. This includes de-energizing circuits before working on them, using appropriate personal protective equipment, or PPE, and testing circuits to verify they are de-energized. Never work on live circuits unless absolutely necessary, and only then with proper training and equipment. If you are not qualified to perform electrical work, hire a licensed electrician. Improper electrical work can be dangerous and can result in serious injury or death. The information provided here is for general guidance only. Always consult with a qualified electrician or electrical engineer for specific advice on electrical installations and safety. Understanding the pros, cons, and issues associated with different voltages and wiring configurations, along with adhering to the NEC and local codes, is crucial for ensuring safe and efficient electrical systems. Different voltages, such as 120 volts, 240 volts, and 480 volts, serve different purposes based on their capacity and safety considerations. 120 volts is commonly used in residential settings for standard appliances due to its low risk of electric shock, whereas 240 volts is employed for higher power appliances like dryers and ovens. 480 volts is typically reserved for industrial applications due to its high power capacity and the need for specialized training and safety precautions. Wiring types, including 2-wire, 3-wire, and dedicated circuits, also play a critical role in electrical systems. 2-wire systems are suitable for basic lighting, while 3-wire systems offer improved grounding for higher power circuits. Dedicated circuits are used for specific appliances, preventing overloading and ensuring consistent power. Additionally, consider the impact of voltage drop. Voltage drop is the decrease in voltage along a conductor. Excessive voltage drop can cause equipment to operate inefficiently or malfunction. To minimize voltage drop, use appropriately sized conductors and keep circuit lengths as short as possible. The NEC provides guidelines for limiting voltage drop in branch circuits and feeders. Regular inspection and maintenance are crucial for ensuring the safety and reliability of electrical systems. Inspect electrical equipment for signs of damage or wear. Replace damaged or worn components promptly. Test ground fault circuit interrupters and arc fault circuit interrupters regularly to ensure they are functioning properly. Keep electrical panels and equipment clean and free of obstructions. Proper planning and design are essential for creating safe and efficient electrical systems. Determine the electrical needs of the building or facility. Select appropriate voltages and wiring configurations for the intended use. Design circuits to minimize voltage drop and prevent overloading. Install adequate grounding and bonding systems. Provide overcurrent protection for all circuits. Consider future electrical needs and provide for expansion. Effective troubleshooting techniques are essential for identifying and resolving electrical problems. Use appropriate test equipment, such as multimeters and circuit tracers, to diagnose electrical issues. Follow safe work practices when troubleshooting electrical circuits. Consult with a qualified electrician if you are unable to resolve the problem yourself. Improving energy efficiency in electrical systems can save money and reduce environmental impact. Use energy-efficient lighting in appliances. Install occupancy sensors to turn off lights when rooms are unoccupied. Use timers to control lighting and equipment. Optimize motor performance by using variable frequency drives, or VFDs. Implement power factor correction to reduce energy losses. Furthermore, consider surge protection. Surge protection devices, or SPDs, protect electrical equipment from voltage surges caused by lightning or other events. Install SPD at the service entrance and at sensitive electronic equipment. Regularly inspect and test SPD to ensure they are functioning properly. Now consider harmonics. Harmonics are distortions in the electrical waveform caused by nonlinear loads, such as electronic equipment. Harmonics can cause overheating of equipment, nuisance, tripping of circuit breakers, and other problems. Mitigate harmonics by using harmonic filters or by specifying equipment with low harmonic distortion. Also consider power quality monitoring. Power quality monitoring systems can provide valuable information about the performance of electrical systems. These systems can detect voltage sags, swells, transients, and other power quality problems. Use power quality monitoring data to identify and address potential issues before they cause equipment damage or downtime. When working with electrical systems, always prioritize safety. Follow lockout-tagout procedures to de-energize circuits before working on them. Use appropriate personal protective equipment, including gloves, eye protection, and insulated tools. Work with a qualified electrician if you are not comfortable performing electrical work yourself. The NEC is updated every 3 years to reflect changes in technology and best practices. Stay up to date on the latest NEC requirements to ensure your electrical installations are safe and compliant. Consider attending electrical training courses and seminars to enhance your knowledge and skills. Proper electrical system design, installation, and maintenance are critical for ensuring the safety and reliability of electrical systems. By understanding the principles of electrical engineering and following industry best practices, you can create electrical systems that are safe, efficient, and reliable. Remember, electrical work can be dangerous. If you are not qualified to perform electrical work, hire a licensed electrician. Improper electrical work can be dangerous and can result in serious injury or death. This overview should provide a solid foundation for understanding the key considerations when working with different voltages and wiring configurations. Always prioritize safety and consult with qualified professionals for specific applications.